Welcome to the AMD Software Optimization video series for the third generation AMD Opteron processor. Our goal here is to share knowledge about the performance potential of this family of processors so that by taking advantage of optimization techniques, you can deploy the best possible applications. This series of video presentations is a companion to the AMD Software Optimization Guide for Family 10 processors. It's found on our website at developer.amd.com. Much of the content is based on that document, but here we'll expand on some concepts and show some concrete examples. The recommendations in this series are intended to help you improve the performance of software applications on our new processor family. You'll learn about the microarchitecture of the third generation Opteron processor, how we sped up memory access using prefetch, hypertransport technology, and out-of-order memory loads. We'll look at sample algorithms and how the code is executed in new ways, and we'll demonstrate how this new processor builds on the advancements made in previous generation processors. You'll gain a deeper understanding of the methods and practices to optimize your code and maximize its performance. The new processor family makes no compromises in performance or power efficiency. We've built on past innovations to provide breakthroughs in speed and energy costs. We dynamically power down memory and logic when parts of the platform are not in use. You'll be able to create applications that deliver exceptional results while helping to decrease costs. The third generation Opteron processor enables everyday breakthroughs. We welcome your participation in delivering industry-defining performance per watt. The subjects we'll be covering after an overview of microarchitecture are branch prediction, decoding procedures, data dispatch, ALU and FPU behaviors. We'll examine load store and data caching and finish up with the operation of the memory control hub. Throughout this presentation, we'll clarify differences in the new processor from previous generation AMD Opteron processors, pointing out new characteristics and underlining appropriate optimization techniques. We start with the assumption that you know the x86 microarchitecture. You'll see many things that look familiar, but this third generation processor has some new features. We'll make it obvious with color coding and other visual emphasis when we're highlighting something new and different. Let's start with the microarchitecture. This is the third generation AMD Opteron processor block diagram. It's similar to the previous generation with many common features, but it adds important new ones as well. The third generation Opteron processor introduces a revolutionary native quad-core design and a new L3 cache. Second generation Opteron processors only went up to dual-core, with a variation in cache size and number of cores. These powerful new features can deliver increased processing efficiency. The superscalar integer unit significantly speeds processing. Our 12-stage pipeline is one stage longer than our second generation AMD processor. This is a 3-issue processor, so based on this architecture, most processing is arranged in triplets. When dealing with instructions, we have 3 decoders all the way through. Our superscalar 3-way floating point unit is also super pipelined. It's 128 bits wide, which means it can achieve 4 or 8 flops per cycle, double or single precision. Each core has 64K instruction cache, 512K L2 cache, and shared among all the cores is the new L3 cache that can go up to 6 megabytes depending on the configuration. Something you'll notice in simulations is out-of-order loads. The processor retains its in-order retirement, but loads are done out of order. This feature combined with prefetch and branch prediction can dramatically accelerate processing. There are several abbreviations that will be familiar to you. AGU is Address Generation Unit. ALU, of course, is Arithmetic Logic Unit. ABM is Advanced Bit Manipulations, part of the new set of instructions. Second generation AMD Opteron processors had an onboard memory controller closely coupled to the processor. We now provide 2 memory controllers. We've done this because the third generation Opteron processor has up to 4 cores, and having additional memory bandwidth is crucial to keeping these cores working at peak. Our goal is to make sure that the delivered bandwidth, not the theoretical bandwidth, is maximized, particularly when you have multiple cores making demands on the memory subsystem. The two memory controllers ensure that when multiple processors are running concurrently with different memory patterns, each processor gets a reasonable share of the memory bandwidth. A new feature of the memory controller is a memory prefetcher added close to the memory. It speculatively opens RAM pages and is intended to improve the delivered bandwidth inside the processor. We've also added a memory write buffer. We think this is significant because the time cost of switching from read to write mode in current RAM protocols is steep. The internal memory write buffer permits all writes to be accumulated so you won't have as many direction switches in the RAM protocol. And of course, the third generation AMD processor has hypertransport technology, which grabs memory blocks faster and permits glueless multiprocessing. We'll go into details on all that I've sketched in the chapters that follow. A powerful new generation of AMD Opteron processor is here. Programmed with best practices, a whole new realm of applications become possible. Thanks for your support of AMD. We welcome your feedback and your participation in our open initiatives. Let's build a multi-threaded superscalar future together.